Hello again. This is second part, like first part, but previous was introduction and now it's first part here. Today I want to talk about Microsoft Agent Framework and Microsoft.Extensions.AI. These two libraries, frameworks, the key part of any AI development in C# and .NET. So let's jump into it. So we will start with Microsoft Extensions.AI. It's a core library of Microsoft AI. Technically, you have two interfaces. If you don't know interfaces, it's kind of public contract that this library can provide. So first of all, it's an iChat client, which represent actual chat with LLM. And they support many different providers. Like in this example, for example, it's Alama. And we can get chat response, we can get streaming chat response, different roles. It's allow us to call tools, which is again critical important. There's a different type of tools like AI functions or Azure Foundry. Azure Foundry, it's in case if you wanna use Azure AI and use this AI Azure stuff. Really powerful here. How you can call it, invocation, stuff like this. Again, I'm probably keep this link in description for this video so you can check it by yourself. Of course, cache response, telemetry is super important because based on that library, I built functionalities that now this startup it's called Langfuse or stuff like this for telemetry. Easy to build with this application and codecs in 2 days. You will have whatever you want. Whatever. So this library provide all this information about that. And technically, what's it all? Okay, middleware. It's the same middleware as middleware in ASP.NET. You can interrupt execution flow and collect data or put some protection, filtering, whatever stuff you want to put. I really love this concept. This is really amazing. Of course, dependency injections, states, stuff like this. So iChat client. This is what we use for override in case if we want to provide access to new provider or cloud provider or local provider. Second one, it's a embedding generator. It's a way how you can generate embeddings, obviously. Kind of the same. Kind of the same, everything here. Really nice interface. Again, you can connect to different providers. I really love this concurrency limiter because sometimes if we talk about local development and local models like this, for example, performance is really limited because of your local machine. So in this case, if you run in parallel several requests, probably you will wait too long until it will be finalized. So amazing one. Microsoft Agent Framework. We will jump to it a bit later. So next thing, it's what we also should know, of course, it's MCP, because we will use MCP as a provider for tools and abilities for our agents. We will be able to connect local MCPs and remote MCPs. And also I will show you technique how you can actually connect in like 500 tools at the same time and your model will still perform nice. This is also really, really important part. It's a way how you can connect already made it, this tools MCP with your model. And probably your question will be, what is the difference between tools and MCP? Technically, there is no difference. Tools you put by yourself, but MCP developed by someone else. You just connect it, but technically execution the same. Speak, quick starts, concepts. I really, really, really want you to jump into it, at least really briefly. There is explanation what agents are, these tokens, what this token means, because still a lot of people have no idea what is tokens, and sometimes they think it's a letter, but it's not a letter. This is explanation. What is this exactly? So as you can see, tokens, it's a way how model understand words. They have this token process, token structure, which each word, like I, for example, or some several maybe words or letters connected, and they create these numbers, and then the numbers, we send these numbers into LLM, and LLM process these numbers and these numbers back, and the tokenizer again convert this into text we really understand. So a lot of core concepts here. Again, a lot of explanation about tools, all this chain of thoughts stuff. Mm, Again, also really interested. It's a text to image. The same thing. Maybe we want to generate images. Still, a lot of people want to run locally their models for video. But again, after Sedan's released, I don't see any reason why you should do this, except you have, like, I don't know, GPU cluster which you keep after trying to mine your bitcoins. RAG also important one. RAG, it's a way how you can make a chat with documents or implement semantic search. Here again, here tokenizer, we can use tokenizer, so really, really nice. All this authentication, which is really important here, it's not responsible AI, of course. Evaluation. Evaluation provide libraries and methods how you can evaluate your agent. Technically, it looks like this. You have to evaluation set of data. It's a explanation for your dialogues, and you can just play this game with LLM, and you have your question, expected answer, and then LM try to find out if LM answer it in the right way or not so nice way, not right way, and it create for you entire, yeah, this is a library, and it will create for you nice report like this. And so you can find out how your agent is working. So technically, this is a probably really nice way answer to question if your model still behaves as you not model agent, or your agent system still behaves as you expected, or something goes wrong. Only one way to test that, it's provide this data set with question answer. Sometimes it's a multi-turn question answers, and in this case you know, okay, my model still perform, my primary flow still alive. This is a way to do that. So as I said, if you use one fuse or stuff like this, 2 days with codex, and you have your own local implementation for that thing. And technically, this is it. There is a lot of cool stuff around this Microsoft extension AI, but we'll find out it a bit later. Next, most important part on our application, it's a Microsoft Agent Framework. So Agent Framework use AI extension under the hood to interact with LLM. And of course, Agent Framework provides for you a lot of cool stuff. All this explanation, see, you have everything. You have agents. You can use multimodal, obviously. You can have structured output. Structured output in case if your model, this is important one, if your model support that, you can do the structured output. Then model will return you nice formatted JSON. It's really nice if you wanna ask model about some specific thing and you don't wanna parse this text anymore. You can have it structured. Really nice one. Background responses. Also really nice. But again, it should be supported by your model. RAG. RAG system, text search provider. Again, really, really nice to do this. I love this abstraction because under this abstraction, you can put your own implementation and it can be everything, because sometimes it's just RAG system, sometimes it's a graph RAG. Sometimes it's agentic RAG and agentic context, whatever you name it. So really, really cool. Agents. So it's something new. You can define your agent in YAML file and load this. Maybe we will use that for some reason. We will find out. Observability, the same thing as we saw for AI extensions. You can track and see what's going on, how it's executed, and collect some metrics. Also, guys, add skills. So now skills are already built in, and it means you can reuse all the skills from internet in your agent. I think this is pretty amazing. The same thing for tool calls. So again, everything that's kind of based on extensions AI. But now it's agents. So difference here is in extensions AI, you have just interface like iChat client, so it's just you and LLM and that's all. But here now it's inside agent. So agent view, technically the same, it's just wrapper around that. Most important cool part here, it's approval. It's for human in the loop stuff. If it's something critical, you have method to pause your agent execution and wait until you will approve or disapprove that call, which is really, really important for security reason. Already, code interpreter it's for major, we don't need that stuff, all this AI search. We don't need this right now. Host MCP and local MCP2. This is all, and this part is really important because we will host our MCP server, obviously, with our agents and with some local stuff. Again, amazing examples. Technically, it works. So that's why I'm talking about this is the best language and platform and framework right now because everything's so simple. You can connect everything in just by copy this code from documentation. And that's all it will work. And it's pretty safe and it works really fast, which is really important in case if you don't want to pay crazy bucks for this infrastructure, or especially if it works on your local machine, which probably not that super powerful. So see, technically the same all these servers. Cool part here, conversation in memory. So this thing introduce sessions for agents. So it means you can store your session, you can restore your session like this. And this is really important because context is everything. It's super important for agent, and it's really nice that you can manage it somehow. Next one, it's of course the context provider. So it's a way how we can store this context somewhere. In this is a way how we will store our chat history and stuff like this. Of course, storage, perfect. The same thing as we saw before in extension AI. It's a middleware. Again, you can add middleware to like chat, agent, whatever you want, and try to understand what's going on. This guardrails, it's really important because sometimes, but again, it's important if you use some remote model, if you want to try to do jailbreak or stuff like this, probably cloud provider will catch you and they can block your account. Or maybe your clients will try to break your model and you can have your account blocked. But technically, you can implement some protection here. Maybe it will work, maybe it doesn't. It's depend. You stuff like this, and this is all about agents. And also, most important part here, it's a lot of different agents. So we have Copilot. We have also libraries for Codex and for Claude Code. We will use them. So in our application, our dotPilot will be able to work with any providers for this local assistant. Alamo, for example, and Anthropic. It's also already here. But again, this is Anthropic from Azure. Maybe I'm pretty sure there is an implementation for actual Anthropic API. So we will have everything in one place. That's all about agents. Now, most, not most, not least important part also, it's a workflow. Because just agents not enough. All of us have this experience when you have this multi-agent we will build sub-agents. There is no sub-agents yet. But when you can build workflow and you can manage this workflow, it works much, much better. For example, you want to write nice article with AI. And to make that happen, you need, first of all, perform nice research to understand what's going on. Maybe you want to do some cell optimization, geo IO optimization, whatever. So it means you need also correct some keywords and stuff like this. And see, this looks like actual workflow. When you do this, maybe now you need to create draft of your article by some like structure or something, and then fill each piece of your article, because maybe if it's too big, so you'll not be able to just write it in one shot. You need to write it part by part. And then maybe you want to do this, like you want to make it more human readable. So you need to write some skills like humanizer or something to prepare it and then polish and then proofreading and stuff like this. So this is the entire workflow. And this is a way how we can build it. Again, as you can see, everything already here. So all this implemented. Only what you need is to just assemble this piece of software, and that's all. And in next episodes, you will see how we will do this. And again, this is also updated. I didn't saw that. So all these events, executors. Oh, nice! This is so cool. Um, agents with, so again, all this information, how to build it, really, really nice. Man in the loop, checkpoints, the same stuff. See observability, agent with workflow, stuff like this. Really interesting. We will read that. Of course, it's be able to generate this mermaid diagram. And what we really need to know about this, it's a different type of orchestration. There's a sequential, which means like way by one. So in case if you write article sequential, this is your choice. There's a concurrent when, for example, you wanna run parallel several agents, sub-agents who wanna analyze something and then all of them come up with result. It's for this case. And off. Everyone doing everyone. This is complicated for group chat. It's a group chat. You have a chat, this orchestrator, several agents, and they communicate between each other. And magnetic, which is not available for C# yet. Perfect. Of course, there's some integration, Azure functions, stuff like this, protocols. Maybe we don't need that at all. So, this is kind of it. It's our main blocks for building any AI automation, automations, agents, and stuff like this. So I talk about this one and Uno platform, of course, next. So for next thing, we need to come up with kind of architecture for the software, because now we know about agentic framework and extensions AI. And one more time, maybe last thing we should know, it's Arlins. But again, I talked about Arlins before. Let's see. Microsoft Arlins. Okay. Microsoft Arlins. So technically, yeah, this is also important. I think we also have to talk about a bit deeper. So this happens because of grains. Grains, it's a virtual vector. Grain, it's a virtual vector. And virtual vector has some life cycle. As you can see, it's activated. When it's activated, it reads something in memory, its state, if it exists. Now it's be able to accept your request, process request, and then when it's done, it's deactivated and save its state, and that's all. And of course, if you talk about silos, it looks like this. So it's different servers. with a bunch of grains, and grains communicate between each other. Nothing special. And probably that's all in visual representation. And then in Arlins we have a lot of different stuff for streaming, for host, for deployment, but I will show you later how it's going to work, but technically it will be like this. We will have agents, which is created by agent framework, but this agent should be exist somewhere, and this agent will exist in Arlins. So each activation for each agent will be represented as a Arlins grain activation. So it's a kind of a digital twin of this agent. You will have a system prompt for this agent and list of tools or MCP, whatever it's connected to this agent. And then when you need it, it will just create grain and will work inside this grain. In this case, you can run in parallel a lot of agents. All of them will be isolated, or they can communicate between each other. You will see. That's going to be work really, really nice. Also, maybe we can make group chats. We have it in our product. It's called AI-based group chats. It's where you have several, so just group chat in Slack, Teams, whatever. But it's a chat where you have a lot of agents and real people, and everyone can communicate with everyone. It's really interesting in case if it's your home, it's your machine, and you have several different agents for different reason. One, and maybe this is a bit deeper. Maybe each agent it's actual workflow. It's not one agent; it's a group of agent, and then you can do like this. For example, article agent, which is a workflow, create for me my workflow, and then use this MCP tool to post it into my website, for example. That's really cool. So tomorrow, I think we will draw architecture diagram, and maybe we will create our project in Uno platform, so we can have some UI, and we will have some container where we can start this building. And actually, that's all for